there, this is Andrew, and today let's show you how to do the photoelectric effect demo. Photoelectric effect was what gave Einstein's Nobel Prize. He determined that a photon of light coming in from the sky or coming in from a light source, hitting a piece of metal could create an electron to jump off the surface of that metal. And so today we've got the zinc plate as our metal. But before we show you the photoelectric effect, we want to show you first the electroscope and remind you what the electroscope does and is. The electroscope is typically introduced in the first couple weeks of the second semester of physics. We can use the triboelectric effect to remove some electrons from an acrylic rod. Listen to it sparking. Then removing electrons, and I'm using a rabbit fur, and I'm going to put it right here on this top right there. And so now this center bar pulls away from that, and if I put a little charge here, I could push it back a little bit with some electric forces. So now I'm a big body of water, and I can ground it. And there we go, ground it. Now let's quickly charge it up again. Now we can create a positive charge using a glass rod and a paper towel. But this is really hard to do, especially if there's a little humidity. And so if you need to do this, you can put your paper towel in an oven for a few minutes to really cook off and heat any water off the paper towel. Instead of that, though, you can get one of these Flysticks, which is a mini Van de Graaff generator. And you just press the button. It runs on a couple AA batteries. And this top cardboard right here creates a positive charge. And so if I was to see, I can actually pull that toward it now. So now I'm going to go ahead and put a positive charge on there. And now it's positively charged. Once again, I could touch it to release all the charge, or I could create a negative charge and pull this little stick toward it a little bit harder. All right. Okay, so I'm going to ground that, and I'm going to get the zinc plate in. Before I do, I'm going to take a little bit of sandpaper and clean off the little bit of the zinc oxide layer that's built up. So it needs to kind of shiny. And there's oxygen in the air, and there's a little bit of water vapor in the air. It creates a little layer of zinc oxide, not very thick. And I'm going to go ahead and put the plate in sideways so that I can hold it up and show you that I'm not touching it. Okay, so once again, I'm going to put extra electrons onto this electroscope. And sometimes you have to touch it right there because there's a little bit of dirt and the pivots a little bit. Now right here I got a UV light and a piece of glass, and there it's on. Now this glass blocks the UV light but lets the regular colored light through. And so if I hold this up there, nothing happens, and I can hold this up for a long time and nothing happens. Now if I remove this, it will let UV light out that has a higher energy per photon. And so I can hold this right there, and notice, oh, electrons are jumping off, and the electroscope goes back to 0. Now, how do we know that the electron is the part that's holding the charge? Well, we can take extra electrons off using this mini Van de Graaff generator. It creates a positive charge. I'm just going to tap it. And now I have a positive charge. There's less electrons in the system now. Now I can do the same thing, and I can take this, oh, sorry, I touched it with my finger. Let's hurry and charge it up again. There we go. This time I'll be careful not to touch it with my finger. So now I'm shining light on there, and nothing's happening. It's not getting less, it's not getting weaker. The charge is still there. So what's happening is electrons are jumping off this metal plate, but because it's positively charged, the electrons are attracted right back onto the on this plate, and the electrons are negative, and the protons, and the rest of the material is positive. Grounded, and that's it. Thanks for watching.